This you can take as a continuation of our earlier discussed problem. Now we have to find the individual accelerations of the two blocks, capital M and small m masses. I have already marked the forces on the diagram. You can see weight of both capital M, weight is in capital Mg, small m, weight is small mg, marked downwards for both cases. Then the tension in the string. Lower string as tension T marked up here, on the pulley it will be down, up and down T and T. So this T and T, to balance it, it should be 2T on the upper pulley, it will be 2T down here, then 2T up, down here. But what is relevant to us is this 2T and twice of this T. Then on the tension will be acting equal and opposite on either side, so up and down. So the tension on this small m also will be 2T up. So the two forces are mg down and 2T up on the small m. On the capital M, total force upward is 3T and downward force is mg. Then the accelerations. Accelerations I have marked as A1, A2. This acceleration only we want, acceleration of the two masses. When I mark the two accelerations in the same direction, we got a relationship like this, A1 by A2 equal to minus 2 by 3. That minus indicates that the two accelerations can't be in the same direction. So that is why I have retained the small m acceleration down as it is. The larger mass acceleration I have reversed it to A1, so that this minus has no more significance. So you can now go by the numerical value of the accelerations. So we can simply take A1 by A2 equal to A1 by A2 equals 2 by 3, which implies A2 equals 3 by 2 A1. So now we write the force equations. I have marked, arbitrarily marked A1 up, A2 down. Actually, which direction the masses will move depends on the value of the masses. That we shall see later. Now we write the force equations. Force equations for capital M. Force equation for capital M is, we have marked the acceleration up. So upward force must be taken as positive force. Total tension is 3T up. Weight is a negative force, so minus mg equal to m times capital M times A1. Then for the small m, positive force is, weight is the positive force mg, minus tension to T is the negative force, giving us m times A2. So since we solve for A1 first, so that we use the substitution, so the second equation becomes mg minus 2T is equal to m times 3 by 2 A1. Now from the two equations, this equation and this equation, we eliminate T. Eliminating T, what you get is, eliminating T, we get this relationship, 3mg minus 2 capital Mg equals 2m plus a by 2m into a1. So that will give us a1. From this we can get a1. Solving, we get a1 equals, solving a1 is equal to what we get is 2 times 3m minus 2 capital M by 4 capital M plus 9 small m into G. This is what we get for A1. Then substitution for A2 will give you the A2 value also. I will write both accelerations as we require. A1 is equal to 2 times 3 small m minus 2m by 4m plus 9m into G. A2 is equal to, after substitution for that ratio we get 3 times 3m minus 2m into G by 4m plus G. So this section 3m minus 2m by 4m is common for both. Only the ratio 2 by 3 is maintained. Now this information, this final results will give us some further information, that is how the masses depend, the acceleration direction depends on the masses. You can see from the two results. If 3m is greater than 2m, implies both accelerations we have marked directions are correct. Positive, these both will be positive and the marked directions are correct. So that means m will be moving up as we have marked. Small m will be moving down as we have marked. Then the other possibilities through 2m may be larger than 3m. So that means 3m less than 2m. Implies both acceleration will be reversed. A2 will be, A1 both will be reversed, which means this capital M will be moving down, M will be moving down, small m will be moving up. Then we have the special case, both equal, 3m equal to 2m, implies system will be at rest. System will be in equilibrium or system will be at rest. Both, unless you disturb the system, the two will not move. They will remain at rest as it is. System will be at rest. System at rest. At rest means acceleration 0 or acceleration equal to 0. A equal to 0. Acceleration will be 0. That is the meaning, real meaning. Because suppose you disturb it, the system will still move but with uniform velocities. This will move up, this will move down, or according to the ratio. If you disturb it downwards, this will move down, this will move up. Or if you disturb it this way, this can move down, this can move up, but both will move with uniform speeds, uniform velocities. No acceleration, that is the case. And the two velocities, v1, v2 will maintain the same ratio as v1 by v2 equal to 2 by 3. So with that ratio, they will move with the uniform velocity. I think you can understand the solution. So we shall meet again in the next lesson. Thank you.